Hi everyone and welcome to my channel AI with Muzammil and welcome to this 1 hour beautiful journey into the world of Python, or as I call it, the Python road trip. Python is a powerful programming language that has become one of the most popular languages in the world today. So in this video, we're going to start from how to set up Python, and then we're going to cruise out to how you can use different aspects of Python. And by the end of this hour, you will have a solid foundation in Python. So sit back, relax, and let's discover Python. So first things first, we're gonna go onto this website, Miniconda, which is basically a free minimal installer for Conda. And this helps you manage your packages very easily. So you can go onto this website and scroll down a bit, and you can see here in this table that there is installer support for different operating systems with different uh, versions. And you can, depending on your machine, you can install either of these. So I have like 64-bit Windows. I'm going to install it. Once it's downloaded, you can click on it and it's going to open the installation interface. And the installation interface is pretty simple to navigate. You can simply click next, agree the terms, and say next again. The destination folder is correct, and simply you can click on install here. But I've already installed it, so I'm not going to reinstall it. But when you install it here, click on it on this install, it's going to install it for you. And it's a pretty straightforward process. Once you have installed this Miniconda, you're going to hop up onto this Code Studio website. This is VS Code by Microsoft. It's again a very free and most popular editor for different programming languages. You can come here and click on this download, and depending on again on your operating system, you can download it for either of your operating system. I'm going to say Windows, and it's going to start downloading it. And once it's downloaded, I guess um, very soon we can click on it and it's going to open the installation interface. But I've already installed it and it's running in the background, so that's why it says that it's currently running, and that's why it cannot reinstall it. But for you, it's going to be a very straightforward process and you can install it right away. Once you're installed with Miniconda and VS Code, you can go right into VS Code and almost start your Python programming. But before writing your first Python program, the recommended practice is to use different environments. And the purpose of these environments is to isolate different projects from each other. So, because some projects work on, for example, Python 3.6, some works on Python 3.7, and some works on different versions of different languages. So it's always a good practice to create different environments for each project so that you have no compatibility or dependency issues. So right now we are going to create a new environment, and the command for that is conda create dash n, and you can give it any name. So maybe I'm going to give it like my first environment, okay? And then you can also specify which Python version you want to install it. So you can either go for 3.6, you can go for 3.7, I don't know, 8 or 9, whatever, but you can give it any Python version that you want to go for. And 3.7 is basically one of the most used so far, but depending on different projects, you can go for either of the Python version. So let's go for 3.7 because in this we are just gonna have a basic tutorial of how to write a Python program. And you can press enter, and it's gonna start installing it. It asks if you want to proceed, just say yes, and it's gonna install it soon, hopefully. And once it's installed, you can see that it guides you that you have to activate this first. So you have to activate this environment to use it. So you're gonna say conda activate, and then you can write my first env, and it's gonna, you can see the prompt has changed from base to my first env. We can clear the screen, and we are almost ready. Now what we can do is create a new file, save it in this project, and give it a name. maybe hello world, which is one of the most famous opening lines. And remember to save it as Python extension py. This is these files are basically used for Python, and I have a mistake here. .py. Okay. And now we are almost ready. We just want to start programming. So for example, you can say print, and you can say hello world, and then you save it. And the way to do is you can either press this play button over here, or you can also simply say Python, and Python is basically the command, the pre-command, and then you're gonna give the file name, which file do you want to run. And you can also like write half name of the file and then press tab, and it's gonna write it out for you. And this, then press enter, and you can see that here we have successfully created our first Python program. You can also play around with, for example, for I in range, just play around with different programs and print, I don't know, I plus one or whatever. Or maybe you can, yes. So once you saved it, you can see here, if we do it again, we're gonna have it from the counting from 1 to 2. So that's how you're gonna write your first Python code. Data is basically stored in a computer program in terms of in different variables and in different data types. So there are different types of data that we are gonna see now. And then again, we can also use different variable names for this different types of data. The first is, let's say we have a name of a person, and we can name this person as Bob, right? And this basically means a string. So a string is basically a set of different characters small. So we can see that we have a B and then a small o and then a small b. And this is basically a set of different characters. And that's why we call it a string. And it basically refers to the data type str or string. And this is basically used to store different types of strings. It can be names, it can be a detail of a thing, it can be anything that could be written in form of a string. And then we can also print these names a simple way as we did. We can write print, and then we can write print name. And when we run the program, we saw last time that there are two ways to run this program. We can click on this play button, and it will play the or run the program. And we can also write Python, and then write the name of the file, which is which starts for var, and then we can press the tab like this, and it's gonna fill out the rest of the file. And then we can enter, and we see that the name is printed, right? Then the second type of data is integer, and integer can be, let's say, birth year or year, and we can say that Bob was born in 2000, right? Let's assume that the date of birth of Bob was 2000. So this is, as we can see, this is an integer, this is a complete number, and that's exactly why we call it an integer, and short for int. The data type for this year variable or this kind of data are int, and we can similarly also print this year as print year. And we can see here that Python variables, and when I printed it, we can see that it has printed the name and also the year. So that's about string and integers. We have a third type of data, which is basically float, and it can be, let's say, height of the person, height of Bob, and it can be 175 point, let's say, 8 centimeter. And since it involves something right after the integer with a decimal point, that's exactly why we use floating point values for this. And this is basically, this refers to the floating data type, or floating data type of datas. And we can also similarly print the height as something like this. And we can say over here, we can clear the screen to make sure that we have, what we are printing. And we can see that when we run the program, we can print the name of the person, the year of the person he was born, and also the height of the person. These are basically different ways to store the data. We can also combine printing all of them together. But remember that when we try to print something together, so this print function basically it accepts string inputs only. So that's why we uh, only when printing multiple data types. Okay, so when we want to print all of these together, we need to convert these into str or string data type, and that's how only we can print them. So for example, we can do it right away. The name is already in string, so we don't really need to convert it. When we try to convert the year, we can do something like str, and then we can put this year within this str function. It basically tells that convert this year into a string format, and this plus basically means to combine them as in one string. And then we can also combine, let's say, the height of the person like this. And when we try to print it, we can see that we had this Bob printed here, and we had this year, and then we had this height, and then we also have this printed together. So to make it clean, we can first comment it out. And we can also comment this out. By commenting, we mean that when we uh, try to write a hash symbol in front of anything, that basically doesn't run, and the program skips running that instruction. So when we when we have written this hash symbol in front of this print, that basically tells the compiler not to run this specific line, and that's how we can skip specific lines using hash. And it can also be true for like other instructions. And we can say here that then okay, we can say here that the name is we can say the name is or make it simple, the name of the person is name. Okay, and then we can say uh the birth year is birth year. And then we can also say the height is the height. And when we try to print it after clearing up the screen, we can see we have an error that means something's wrong somewhere. And that could be what exactly? Let me figure it out. Okay, what does it say? Bad operand type for... Oh, okay. We have an extra comma here that was creating the issue. Okay, we can run it again, and we can see that it says that the name is Bob, the birth year is 2000, and the height is 175. We can also make it a bit cleaner and do something like this to make it look clearer. And then when we print it again, we can see that it says the name is Bob, the birth year is 2000, and the height is 175 point something. So that's it with the variables. Next, we can move on to different data structures. And for data structures, we have lists, we have tuples, and then we have dictionary. These are basically data structures. And okay, so we can have also these different variables stored within one variable or within one data structure. And for that, we basically use list. And let's say we can also say that my list can have, for example, this name and then the year and then the height. And here we can print the list by saying that it is the list. And when we can print it, we can see that it says Bob 2175.8. Now, this list basically contains these different variables that we have already defined up there, but we can also assign it from the very start. We can say that store a new name and call it Anna, and maybe like a new date of birth, I don't know, 2002, and then also height, make it 180, and store it as my new list. And when we try to print it, we can see that it's going to print the new data that's stored in here. We can also see how many entries do we have in this specific list. And the way to do it is you call the length function on this list and print it out. And when we try to run this program, we can see that it says 3. For convenience, we can remove printing it out. So now if we see it again, we can see that it says 3. So we have 3 elements in here. And then we can also access each of the indexed item here. So indexing in Python starts from 0. So if you want to access the very first item, we have to say 0. And when we print it, it's going to say Anna, which is on the first item. We can say the second one, it's going to print it out the year she was born. And on the second, which is basically the third, we have 180, which is the height. And what happens if we access the third index? It says list index out of range. So it basically throws an index error. And that's basically that we only have 3 elements over here. And while we are trying to access the fourth element, which is in index basically 3. That's why we cannot really access that. Similarly, we can also have what we call as tuple, tuple, and tuples are basically created using these small brackets. So this is basically list. This is basically tuple, and it also does the same what we did with the list. If we print it out, it does the same process, but we can see that it shows that in small brackets, meaning that it's tuple. We can also in a similar way try to print the first entry and the second entry. We can also change it. So let's say Sophia, and then we print it out. It's gonna say Sophia. But the difference between list is that list is mutable, mutable, and the tuples are immutable. Okay, this means that the lists can be changed, but the tuple cannot be changed. So, for example, if I print my list here, and I want to see what is the first entry of the list, it's gonna say the first entry of the list is Anna, but I want to change the first entry of the list. Okay, I want to say the first entry of the list is, let's say, I don't know, Irfan. Okay, so when I gonna print it out, it's gonna show Irfan. So it has actually changed the first entry of the list here. But if I try to do something similar, and for example, before that, I would try to see what my tuple is. And if I try to print it out, I can see that it says Sophia. So the first element of the tuple is Sophia. And if I want to change the first entry of my tuple by doing something like my tuple of 0, change it to Irfan, and try to print it out, we can see that we have a type error. The tuple object does not support item assignment. So this means that it cannot really assign anything to the tuple after it has been created. And that's the difference between my list and the tuple. That's it for this list and tuple. And then we have the last is at my dictionary. And basically, the way to represent a dictionary is these curly brackets. Dictionary basically, or dictionary, they have, they basically represent a key value pair. Okay, key value pair. And this basically means that we can have, let's say, a name as a key to some data, and then we can also assign what is the name of the person. So we can say that the name of the person is Eva Max, okay? And then we can also assign the age of the person uh, as a key, okay? We can say that the age of the person is, we can store it as integer, let's say 20. Let's make it 20. That sounds a bit realistic for them. And then the last entry we can assign, let's say, a year of birth. Okay, and we can say, let's say that the year of birth is should be 2002. And when we try to print the dictionary over here, we can also say print and my dictionary. And when you try to print it out, we can see that it prints out the dictionary with name, Evermax, and age, 20, and year. We can also access the keys of this dictionary only by printing my dictionary.keys. So it will tell us what are the keys of these dictionaries. We have name, age, and year. And then we can also access the values of these dictionaries. And it can tell you the values are Evermax, 20, and 2022, 2002. That's one way to do it. Another way to store a dictionary or use a dictionary is that you can also assign different names. So instead of one name, you can say that the names, and then you can write the names as, let's say, a list, and the list can contain multiple names: Anna, Sophia, and let's say we have Irfan. Okay, and then you can also have a different key as age. Okay, and you can assign the age as another list. So we have, let's say, okay, oops, right. So we have ages for Anna. Let's say she was, I don't know, 20, and let's say Sophia is 18, and let's say Irfan is 45. Okay, and then we can write my dictionary, and we can see what do we have in here. We can see that the names in the dictionary, we have Anna, Sophia, and Irfan, and we have their ages at 20, 18, and 45. So we can also store multiple sets of data in dictionary for each key. So we can have a key, and we can also store, let's say, a tuple or a list for that specific key, and then we can also have another key with another list, and then it can keep on going more complex, and we can add on more data in this format. So that's how we use dictionary. So we had three different data structures here in Python: my list, my tuple, lists, tuple, and dictionary. You can change these names as per your convenience. These are just for your own convenience. You can write a very suitable names the way that it suits you. And yeah, just remember to use it properly. Yes, that's pretty much it from this tutorial. Besides, by the way, these data structures or data types, we also have some other data types, but those are kind of beyond the scope of this basic tutorial, so we are not going to really discuss them. These are the most used ones, and that would suffice for this tutorial. Now we're gonna work on two things. The first is how to take input from the console, And in Python, there is this function called input that you can use to take input from the console. And you can also enter a prompt. For example, you can ask the user to enter your name, and then you can assign whatever they enter from the console to a variable. So you can, let's say, assign it to my input. Okay, so whatever the user will write here in my, it will come into my input, and then you can also try to see what they have printed. For example, you can say print what is my prompt. So we can start the program by saying Python, and then the name of the file is input and logical operators. So it says enter your name, and for example, you can say the name is Sophia, and you can see that the name has been printed here. One thing that I would like to mention here is that this input function, the input is always a string. Okay, so in Python, whenever you use this input function, whatever comes into this variable, the data type or the class of this input is always a string. So you can also check what is the type of my input. You can try to print it out, and we can see here that when we try, let's say we write Sophia, and when we try to see what is the type of the input, it says that it's a string. So in case you would want to use numbers, for example, um, let me use another one. So for example, we try to enter num1. So enter num1, and then you can also have num2. So you want the user to input two numbers, and then you would like to add the two numbers. So num1 plus num2. Now if I try to do it as is, it's not gonna add the two numbers. So if we run it, so let's say I enter the number 1 as 1 and the number 2 as 2. So we expect that the two numbers we added should be 1 plus 2 equals 3. But instead, since now this is a string data type, what this plus does is basically concatenates the two numbers. So that's why it appends the second number to the first one, and that's why it appears in 1, 2. So in order to use the number, the integer data type, what you can do is convert this number to an integer format. And similar goes for the second one. You can also append this or convert this into the number integer data type. The way to do it is you use this integer function to convert it. And when we try to do it here again, we can see that the number 1 is, let's say, 1, the number 2 is 2. We get the sum of 3. Similarly, you can also use this float data type. So in order to take into account float variables, 2.3 something or whatever, 0.9. So you can see that we have now added the sum to a 3.5, and that's how you take inputs here in Python. Then we are going to talk about logical operators. And in Python, there is a very easy way of handling things. So for example, so let's start with an example. Let's say we have a price of a car, which is, let's say, 2000. And now we want to see if the price of a car is less than certain threshold. So we can say if price of a car is less than 100. Okay. So what this will do, this statement over here, it will try to see if the price of the car is less than 100. So if it is less than 100, it's going to print true. And if it's not less than 100, it's going to print false. So we expect here, So we expect here that it will return false because the price of the car is not less than 100. Now, if we say if the price of the car is less than 5,000, we expect that it's going to return true because the price of the car is indeed less than 5,000. We can also combine this with with multi logic. So we can also say return true if both of these statements true. For example, we can say if it's greater than uh, let's say 3000, and we can try to run, and then I can explain how it works. So we have an overall output of false. Now how this works is that it first checks this and then checks this as well, and then takes an OR logic operator between them. So in terms of here, how it works is that it's for example, it checks if the price of the car is less than 500, which it is not, so it's gonna return false. And then we have an OR logic operator in the center, and then it's gonna check if the price of the car is greater than 3000, which it is not, so it's gonna return false as well. And false or false is also true. So for the OR operator, if any one of the logics is true, it's gonna return true. Sorry, I meant false. And if all of them are false, so we're gonna have a false. So now if we can, for example, change it, and we can say that if the price of the car is greater than 1000, so now in this case again, this statement returns false, but this statement is gonna return true like this. So we will have an output of true, and we can verify it over here. We can check that it returns true. Now similarly, we can also try to see an AND gate. Now how AND gate works is basically it checks this first, so it's going to return false, and then there is an AND gate in between. We have an AND or AND operator, logical operator, and then it also has this price of car which is actually greater than 1000, so it's going to return true. But for AND gate to return true, all of the statements should have a true, but we have one false, so a result will be false. And we can verify this here as well, that we have an output of false. And that's how we can check these statements. One final way of doing is we can also have a combination of, let's say, these. We can say or price of car is equals to 2000, let's say. Okay, and we're gonna work on that later, but I can show it to you how it works. So it basically returns true. Now how this works is that we have this and this, so we have something like false and true, and then we also have OR, which is this, and this basically returns true. So equal means it compares this with this amount. So is the price of car equals 2000? And we know that yes, the price of the car is actually equal to 2000, so it's gonna return true over here. And that's why when we have a false and true, it's gonna return a false, but then we have an OR with true, so we're gonna have a finalized true output here. Yes, so this is pretty much it from the logical operators. One last thing that I should also talk about is let's say the data type. So we can also check what is the type of the data of this this variable. So we can say, is the type of variable int? Okay, so that's the way how you check it. So type of the variable is int, and we see that this is indeed an int here. Okay, because this is a whole number, and then we would expect that this would return actually true. So this basically returns true because the type of the this variable or the class is indeed an integer. We can also check if it is an str. Now we know that this is an integer, so it's not an str, and we would expect that this returns false. And we can check it here that this returns false. The other way to check and finalize it also to use is not. So we can say the price of the car or the type of this variable is not str, and we see that this would return true. So there's multiple ways of checking these inputs to use these logical operators and to get the task done, but you need to know that which way is optimal and which ways you can use. So there is a variety of ways how you can do that. Of conditional statements, it basically involves if and else statements. And these basically kind of statements are used to conditionalize certain a part of code. And when we want to, like, for example, put a condition on certain block of code, we can use these kind of statements. And I can explain it by example. So one example is that, let's say we have a temperature, and we would like to print out certain print statements based on what the temperature is. So let's say if it's very hot and it's, let's say, greater than 35 or 30 degrees C, we can print out to the screen that it is very hot today. And if it is between, let's say, 15 to 30, we can say that it is pretty okay. If it is below than 15 degrees centigrade, we can print out to the screen that it's very cold today. So in this example, in this way, we would learn how we can use this if and else condition statements. And let's say we have a temperature variable, and the value we can assign it anything right now at the moment. Let's say 20. And the way to execute if and else statement is we have this if keyword. We should define like if, and then we put the comparison statement. So we can say if the temperature is greater than 20, or let's say 25, then we put a colon here to define that this is the end of this if line. And then in the next line, remember that whatever we write, so in other programming languages, let's say in C or C++, or even let's say in MATLAB, what we do is that we have this if condition, and then we have an end over here, okay, to define that this is the end of this if block. But in Python, instead of doing like something like if and then writing stuff here, we do not do this kind of stuff. What we do is that we do not write an end statement, and whatever comes within this if block, we put it in indentation here. So as you can see, if I press an enter from here, it automatically gives this 4 spaces here. So you can also manually put 4 spaces, like 1, 2, 3, 4, and you can also press the tab button, so you can have automatic 4 spaces. Or in VS Code, you can just press from this line, at the end of this line, you can press enter, and you will have the indentation. So whatever you want to print, when this statement gets true, you can print it here. So let's say we can say print, and the temperature is greater than 25. It should be hot, or it is hot today, right? And we can run the program and see how it works. But we should make the temperature, let's say, 35, and then I can explain why after Python and condition, and we can see that it says it is hot today, and that's because the temperature is indeed greater than 25. What if the temperature is less than 25? So let's say if the temperature value is 25 and it compares this value, so this will not hold true, and let's see what it does. So as you can see, it has not printed anything because this condition has not turned true, and that's why we cannot really print it out. So to avoid certain situations, we can also put else kind of statements, or if. So we have this if, which basically resembles else if, and you can say that if temperature is less than 25, okay, you can say it is cold. It is cold today, right? And we can again print it out, and we can say that, although we have to save it, yes. If we run it, it says it is cold today. So if the temperature is 20, it says it is cold today because it's less than 25. And when it's greater than 25, let's say I put it 100, it will say it is hot today. But one thing we need to look, like if I put 25 here, it's not going to run anything because we have the condition for when the temperature is greater than 25, and when it is less than 25, but we do not have any statement when it is equal to. So we can either put, let's say here, greater than equal to 25, or we can also put greater than equal to here, and less than equal to here, to assign this value as well. We can also put certain like chunks of this threshold. So you can say, for convenience, let's say if it is greater than 30, right, it is hot today. Okay, we can say that if the temperature is less than 30 and the temperature is greater than let's say 20, so if it is in the range of 20 to 30, we can say that it is pretty okay today. And we can also write as if temperature is less than let's say 20, but it is greater than let's say 5, and we can print it out again that it is cold today. And we can also finally put else. So basically this would invoke all the values when the temperature is less than 5, sorry, 5 or equal to 5. And we can say that print it is freezing today. Okay, so let me explain it. So this basically this part of the condition would say that the temperature greater than 30 would be hot. It would print that it is hot. And when the temperature is less than 30 but it is greater than 20, so the temperature is from 20 to 30, it would print it is pretty okay today. And the temperature less than 20 but greater than 5, so from 5 to 20, it should say it is cold today. And anything else, so anything other than this, which basically means when the temperature is less than 5 or equal to 5, or it goes in the negative, it should say that it is freezing today. Okay, so let's run with different values. Let's say we have a temperature of 100. We should see that it says it is hot today. We can put certain value between 20 to 30. Let's say we have 25. It should print out it is pretty okay today, so it's kind of a room temperature. And when it goes down to from 5 to 20, any value, I don't know, 12, and let's run it again, and it should say it is cold today. And let's put like very negative values, because anything less than 5 should print this value out, so we can confirm that as well. It is freezing today. And that's how you basically use these if else statements. And you can also like extend this to different scenarios where you have multiple if and else conditions, and then based on the situation that you have, you can put it in different formats. Okay, then we're gonna talk about loops in Python. Okay, and one of the so there are two kind of famous loops. One is while and the other is for loops. And the loops basically helps you iterate over different things. So when you want to iterate over a number of different things, you can use loops in that scenarios. And for example, one very simple way is you want to print out. So for convenience, let's comment this out. Okay. Now let's say you would want to print I am okay. And you, for some reason, for whatever reason, you would want to print it 10 times, right? So the pretty, okayish way, or pretty simple way would be to, simple is in turn a relative term, but let's say a very easy way would be to write it 10 times. Or let's say you would want to print it 5 times, okay? So you can do it, you can write it 5 times. And when you run this statement, you can say that it has printed out 5 times, I'm okay. But let's say you have to print it out for 1,000 times or billion times or even a gazillion times, or it's not really about printing. If you would want to iterate over different things, and you have to do one task multiple times with multiple iterations. So you cannot really, do it again and again. So for that, we have loops. And the loops basically here is very simple. The concept of loops is, for example, let's talk about while loop. So while loop says, let's say you have the iteration, you would want to have a max iterations of 5. So you would want to repeat it for 5 times. So what you can do, and you can also start with I equal to 0, iteration, let's name it iteration equal to 0. And you can say while I iteration is less than equal to max iteration, and then you put this colon over here. So what you want to say is print I am okay. Okay. Now what it does that it checks, it will loop over this, it will iterate over this while this value holds true. So while the value of iteration right now it is 0 is less than or equal to 5, or for it should be less than 5. It shouldn't be here less than max iteration. So while the value of iteration is less than max iteration, it's going to print it out, this value. Now we also have to update the value of iteration over here. So what we can do is here, iteration is equal to iteration plus 1. Okay, we can do either that, or we can also do something like iteration plus equals to 1, which is basically similar to iteration plus 1. Okay, so what we do is that we check this value, we print it out, and then we also update this value. So iteration starts from 0. When it when it prints it for the first time, it's going to update its value from 0 to 1, and so on. It's going to keep updating it until it reaches 5. And we can see that when we run the program, we have 5 times this printed out. And the reason, because when it reaches at the value of 5, let's say when we have 5 and then here it updates with plus 1, so the iteration becomes 6. And when it comes again to this while loop, it checks against this condition, that is the iteration value less than max iterations. So in that case, it doesn't hold true, and that's why it basically runs this program and this while loop. The other way, okay, this was about while loop. The other way to do this is using a for loop, and basically for is one of the most commonly used loops in Python. And the way it works is that you can define, for let's say for iteration, in range. And range basically means, so range is a kind of function when you put max iteration. So let's say for ease, if I put here range 5 and do like this, and I run it, so we can see that we have it printed out for 5 times. And the way it does is that it takes on in this range. So range basically defines how many values you're going to use. So if you say 10, so the range would basically mean from 0 to 9, okay, a total of 10 elements. If you tell it 5 values, a max of 5 iterations, so the range function, what it does is it creates a list from 0 to 4, so a total of 5 values, and that's how it iterates over it. You can also define the starting point. So by default, range starts from 0, okay, but you can also tell it, and it ends, okay. Well, let's not make it very complex. So you can also define start, I guess, as 1, okay. So you can also define start, or just maybe say start, okay, and you can print it out. And in this case, since the range by default starts from 0 and it goes up till 4, so 0, 1, 2, 3, 4, a total of 5 values. When we give it a starting point of 1, so it's going to go from 1, 2, 3, 4. And when you start from a different point, it's going to reduce the total number of iterations. So with 0, we have one additional iteration, and that's why it prints basically 5 times this. But with starting from 1, you can also differentiate it to, let's say, start from 1, and then that's why we are having it 4 iterations over here. You can also like for convenience, you can even print this out here. So you can see when we run the loop, so the iteration basically are these numbers, and we can see that it basically runs 1, 2, 3, 4. By default, we can also check it should print 0, 1, 2, 3, 4. Yes, we can see that it runs 0, 1, 2, 3, 4. And then of course there are multiple ways. You can also not really iterate over numbers. You can also let's say you have a list of names. Okay, we have names. Let's revert back to the names list. We had Sophia. Okay, and then we have I don't know, we had Evermax, and then we can have, let's say, Sarah. Okay, so instead of only iterating over numbers, you can also iterate over names. So you can say something like, okay, let's make it another block here. Okay, you can also say for name and names. Okay, and then you can say print out the name. Okay, so what it does is that it takes these names. Okay, and when you put a name in names, it creates an iteration iteratable over this list, and it fetches each of the index. So we have at index 0 we have the Sophia, at index 1 we have Evermax, and then at the last index we have Sarah. So you can at each index iterate and print out the names. And we can see when we print it out, we have these 4 names. Okay, but you can also apply if name equals, let's say, Irfan. Okay, so you can say print, wow, he is also in the list. Okay, so that's what you kind of can do. We can remove this printing line, and we can see that it's not going to print anything because the name Irfan is not in the list. If you add the name Irfan, okay, something like this, then you can see that it says that, well, he's also in the list. So you can play around with this logics, different logical and conditional statements, and you can basically put whatever you would want to apply and whatever condition or whatever logic that you're really looking into. And this is basically the crux of using for loops. And then we are going to work on create and use functions. And functions are basically a very important part of any programming languages, and they're used to simplify the code and simplify the programs and actually reuse certain blocks and certain parts of code. And they're also used to maintain and for an easier read of the code. So they're basically very important in that regard. And in Python, to create a function, what we do is we define a word, this keyword definition, def, and then we give a name to the function, whatever function that we are trying to create. So for example, we are trying to create a function that would greet someone with their name. So we can call, or we can name this function as greeting function. Okay, and then here in parentheses, in small brackets, what we can do is take an argument. Okay, and this is something that we call from the main program. And then to end this function line, what we do is we put a semicolon, full colon here. And then in the next line, something we can do something like this. So for example, we can write a message, greeting message, and we can say something like this. So this is our function created, and that's about it. It's a very simplistic way to create a function. So you write this definition keyword and then give any name that you would want and take as many arguments as you want. And for example, when you try to call this function, what we can do is basically copy this function's name and give it any name that we would want. So for example, we would call this name Sophia. Okay, And then we can see that when we try to run this function, uh, we can check over here that it prints this message, hello Sophia. And we can also then play around with like other things, make it more cleaner, uh, or like any kind of uh, variations or changes that we would want to do. Okay, so that's how you create a function. That's a very simplistic way of doing it. You can also, since we know that there is one argument or one parameter here, okay, so we would want to pass it on from this end, from when we are calling this function. But you can also define a default value. So for example, you can say that the default value is, let's say, Sarah. Okay, now what it does is that when you call this function, okay, here, and you give it a name, Sophia, so it would basically print that name, or it would take that argument. But when we don't want to give it any name, like when you want to leave it empty, and then you would want to call it, what it would does is that it would take the by default value, which is Sarah here. And we can see that if we don't have any default value, and then we try to call it, we will have uh, an error which says that missing one required positional argument name. So we should assign at least anything to this function. So the ideal practice is to assign at least something like Sarah, or you can also assign it like empty, or even something like none, so that it would not throw this error. That's like one way of using functions. And then there are, like, depending on different scenarios, how you want to call it. It depends on how you can use functions. So you can also, one of the very classical way of using function is, let's say, taking two number and returning sum. So sum function. Okay, and what it does is that it basically takes num1 and num2, and what it does is that print the sum is num1 plus num2. Okay, and you're missing a column here. And what this function basically does is that you can give it two numbers, let's say any two numbers, one and something like 546 or whatever. And what it does is that it basically sums up these two numbers. It can either print it. Okay, so let's run this function. We need to make sure that we have saved this function. So let's run this function, and we can say that it says that the sum is 547. Okay, and you can also, what you can do is, instead of like asking it to print it, you can also get the number from here. So what you can do is you can say that return this value, whatever the value is, and you can get the value here. You can store the value from returning from this function to this sum variable here. You can call it sum value. Okay, and then you can print this sum value here as well, sum value. Oops. Okay, now it should work. Good. And then we can run it again, and we can see that it pretty much does the same thing, or exactly does the same thing. So what it does is that it basically takes on these two numbers and adds them, and then return this added value, and you can then print out here. So that's pretty much it about functions, and it's really a very simplistic explanation of how functions work. Then it, depending on different tasks, it grows more complex, these functions, and then you can use it as per your advantage. But the main idea behind this is to have a reusable block of code, so you do not have to redefine a certain part of the code again and again, and then you can use it very conveniently. Hey, as we come to the end of this video, I want to encourage you all to continue learning and exploring the world of Python. It is a very powerful language that has endless possibilities, and mastering it can open variety of different doors of opportunities for you. Remember, learning a programming language takes time and effort, but with persistence and dedication, you can surely become an expert. Keep practicing your coding skills, try building different and new projects, and don't be afraid to ask for help whenever you need it. Thank you for watching this video, and I hope you found it helpful. Don't forget to like, share, and subscribe to the channel for more informative content. A very good luck on your Python journey.